Hello everyone, how are you all? I am back again with a video lecture on the chapter of matrices and determinant. I hope आप matrices and determinant का जो playlist है आप starting से follow up कर रहे हो. अगर आप follow up नहीं कर रहे हो then you won't be able to make the great advantage of this particular video lectures. ठीक है, so in today's lecture we're gonna basically focus on the other important topics which is in the chapter of matrices and determinant. So I hope from here the chapter and from with today's lecture I will wrap up all the important concept of matrices and determinant chapter. अब जो इसके बाद जो बारी आता है ना, इसके बाद जो मेन इंपॉर्टेंट टॉपिक्स आता है दैट इज ऑन प्रैक्टिस. सो आई विल बी टेकिंग अप द प्रीवियस ईयर क्वेश्चन ऑफ JEE मेंस एंड JEE एडवांस इन द अपकमिंग लेक्चर्स. Okay, and similarly you have to practice on the most important questions as well as simultaneously with me. I will be providing you with the question bank as well as the assignment problems in the description box of today's video. So with this you have to start practicing. Now जो important portion आता है ना, that is when you are done with the chapter you have to revise it. A revision plays a very important role while practicing or preparing for any particular examination. अब revision कैसे करें? कोई भी मान लो आप after a certain period of time you are done up with particular chapter, then you have to revise. So firstly revise करने के लिए आपके पास sources है इस lectures को, तो lectures आपके पास पड़ा हुआ है. You go to the lecture, start watching the lecture in very fast speed, and so that you grasp up the concept little bit faster, and this will be a second time on revising. Okay, and simultaneously go on solving the questions. आप क्वेश्चन का प्रैक्टिस करते करते रिवाइज करिए. दैट इज द बेस्ट वे टू रिवाइज एंड गेट टू द कॉन्सेप्ट्स. ओके, गेट द कॉन्सेप्ट एज योर टिप्स. एग्जाम्स के लिए, एग्जाम पॉइंट ऑफ के लिए रिवीजन इज प्लेज द मोस्ट इंपॉर्टेंट एंड द की रोल. प्रीवियस ईयर क्वेश्चन करते रहिए एंड साइमल्टेनियसली गो ऑन प्रैक्टिसिंग क्वेश्चन फ्रॉम एनीवेयर वेयर एवर यू गेट दिस. I will providing you with the question series in the upcoming lectures also, and simultaneously question banks or assignment problems इस video lecture में मिल जाने वाला है. So with this note, let us start with the today's video. So this is basically about me. If you are knowing me, then well and good. If not, you can read this particular slide. Okay. Now today's goal will basically be on the focus on basically talking about the adjoint of matrix and inverse of matrix का revision. So we will start our lecture with a short revision or important notes on this particular properties of adjoint and inverse. And similarly I move on to solution of simultaneous integration by the method that is known as the Gauss-Jordan method. And after that, if I am done with that Gauss-Jordan method, I will be taking up other important topics, that is a topic of concept of reflection matrix. अब ये जो topic है ना, I will be talking upon this particular topic in the lecture of straight lines. ठीक है, जब मैं straight lines पढ़ाऊँगा तब इसके बारे में मैं ज़्यादा डिटेल में डिस्कस करूँगा. सो इन टूडेज लेक्चर आई वांट बेसिकली टॉक अबाउट द फॉर्मूलाज ऑफ कॉन्सेप्ट ऑफ रिफ्लेक्शन मैट्रिक्स, बट और इसके साथ मैं एक्सप्लेनेशन तो दूंगा ही दूंगा, बट स्ट्रेट लाइन में मैं इसका और ज़्यादा डिटेल और इम्प्लीकेशन अंडरस्टैंडिंग और बन जाएगा. ठीक है, जब वंस आई एम डन विद द स्ट्रेट लाइन्स. तो स्ट्रेट लाइन में मैं रिफ्लेक्शन मैट्रिक्स नहीं भी उसका ऐसे क्वेश्चन आपको सॉल्व कर सकते हो. आई विल टीच अबाउट दैट ऑल्सो. एंड इफ यू डायरेक्टली वांट टू सॉल्व द क्वेश्चन ऑफ रिफ्लेक्शन ऑफ अ पर्टिकुलर पॉइंट अबाउट एनी पर्टिकुलर लाइन, दैट इज नोन एज द कॉन्सेप्ट ऑफ रिफ्लेक्शन मैट्रिक्स. अगर इसको सॉल्व करना चाहते हो बाय द फॉर्मूलाज, देन आज का फॉर्मूलाज तो आपके पास मिलेगा. एंड इफ यू आर नॉट विलिंग टू रिमेंबर एनी फॉर्मूला, तो स्ट्रेट लाइन्स में मैं उसका अंडरस्टैंडिंग दूंगा. ठीक है, आई होप दिस पर्टिकुलर थिंग इज क्लियर. ओके, सो लेट अस स्टार्ट विद द डिवीजन ऑन एडजॉइंट एंड इनवर्स. सो सबसे पहले एडजॉइंट ऑफ मैट्रिक्स हम किसको बोले थे ना, एडजॉइंट फॉर एग्जांपल एनी स्क्वायर मैट्रिक्स के लिए एडजॉइंट डिफाइन किया जाता है. तो स्क्वायर मैट्रिक्स मान लो ए है, ओके, एंड देन वी डिफाइन एडजॉइंट ऑफ ए एस द कोफैक्टर एलिमेंट्स का अगर मैट्रिक्स बना दो एंड वी टेक द ट्रांसपोज ऑफ दैट पर्टिकुलर मैट्रिक्स, देन वी गेट द एडजॉइंट ऑफ मैट्रिक्स. एंड सिमिलरली इनवर्स ऑफ मैट्रिक्स इज डिफाइंड फॉर अ स्क्वायर मैट्रिक्स such that A inverse is actually defined in the fashion that A inverse is equal to adjoint of A divided by determinant of A. So I hope this particular two things was clear from the previous lecture. तो ये वाला तो clear हो चुका होगा. Now let us talk about some important note which comes very handy in problem solving in the examinations. Okay, तो सबसे पहले before talking about inverse we also studied the inverse तभी होता है any square matrix is invertible or it is said to be invertible only and only when determinant of A is not equal to 0. is only and only when determinant of A is not equal to 0. तो क्वेश्चन में आपको ये लैंग्वेज भी देखने को मिलेगा that a given matrix is invertible, that means the given matrix inverse exists, that means the mod of that is the determinant of that particular matrix is non-zero. So I hope these types of questions will be easy to tackle. Okay, now let us study some important note, that is if a square matrix A is given and its inverse matrix is represented by A inverse, then we can relate some important features. That is, for example, A is a symmetric matrix, then I can comment on the nature of A inverse, and I can say that this particular matrix will also be symmetric. And if I say that A is a diagonal matrix, then I can also say that A inverse will be again a diagonal matrix. Similarly, if I say A is a triangular matrix, then I can also go on and say that A inverse will also be a triangular matrix. So I hope this particular important note will be taken care of while solving important questions. Okay. Now similarly, let us go on. We also know that I का अगर inverse निकालोगे ना, that is equal to I. And similarly, if you go and compute this particular result, that is A inverse की whole की power k is similar to A की power k की power inverse. So I hope this particular result is also very handy and comes useful. Okay. Similarly, there is another important concept that if you multiply any scalar with a matrix and takes the inverse of whole, then this is similar to equivalent to taking 1 by k times of A inverse. Okay. Now where k ka value is non-zero, where the value of k is not zero. Similarly, another important thing, for example, A is a diagonal matrix and it is given by the diagonal elements. For example, the diagonal matrix is represented by DIAG, this word, which means the diagonal elements, and are represented as D1 and D2 and D3 and so on. If these elements are given, and if you calculate and you set to compute the inverse of this particular matrix, then you can directly write this particular inverse as diagonal of 1 by D1, 1 by D2, and simultaneously goes on. Okay, so this is how you will calculate the inverse of a diagonal matrix. Okay, now let us move on to the another important property that comes very handy in solving some important questions. Okay, now I will rub this particular portion. Okay, I hope you have taken notes of these particular things. Notes बनाते रहो, ठीक है. Simultaneously go on taking up notes and solve the questions in a rough notebook or whatever you are doing. And उसके बाद तो lecture notes तो description box में available है. So from there you go on and make the proper notes. Okay. Now let us I talked about an important property in the last class, that is A, that is basically adjoint of A inverse is equal to adjoint of A का whole का inverse. Okay. Now this particular property also comes very handy if you know the proof of the particular result. Okay, so if you are able to prove this particular result, okay, now how to prove this particular result? Now we can say one thing, that if we multiply A into A inverse, then we get an identity matrix. Similar to this, if I take adjoint of both the side, what I will be left with, A into A inverse is equal to identity matrix. Adjoint of identity matrix is basically identity matrix, and adjoint of product is actually opened like something like this, that is adjoint of A inverse into adjoint of A. Okay, and this is equal to identity matrix. Okay, so from here I can say one thing, and comment on basically of this particular nature, that is adjoint of A inverse is based in multiplied by some another matrix which gives the result as identity matrix. So from here I can say कि adjoint का of A, इसका अगर पूरा inverse निकालो तो this particular result will be equal to this particular matrix only. Okay, that is adjoint of A inverse. So how we can say this? Because I have already talked upon that कोई square matrix है, अगर ऐसा कोई matrix से multiply करो ताकि the result is identity matrix, then such particular this particular unknown matrix is known as the inverse matrix. So from here I can prove and say that adjoint of A inverse is equal to adjoint of A का whole का inverse. I hope this proof was clear. Okay. Now another important proof I have also talked about on regarding this particular concept only. Let me rub this. Okay. Now I have also talked about another important property, that is A inverse is basically equal to adjoint of A by determinant of A. Now from here what I can get and approach a result, an important result, that is A inverse into determinant of A is equal to adjoint of A. Okay. Now from here what I can do, I can do one more important thing, that is I can take this particular determinant on both the side and I can write this A inverse का determinant into A का determinant, and determinant of A is basically a constant which is multiplied to the scalar, so determinant of A की power n. Okay. Now if I divide it and write this, and adjoint of A, that is equal to determinant of A की power n minus 1. Okay, so from here I will also get an important result, that is A inverse का determinant होता है, that is equal to 1 by determinant of A. So I hope this particular property was clear. Okay, so I hope this particular property was clear. Okay, now another important result that comes very handy that comes very handy was this particular property, that is adjoint of A inverse is basically equal to matrix A divided by determinant of A is equal to matrix A divided by determinant of A. Now this particular result also comes very handy. Okay, so I hope you will keep remember all these important properties in your mind, so that you can get back to the results, and even if you forget the result in a point of a particular time, you can derive this particular result all from that most important, that is the king rule from the adjoint, that is A into adjoint of A is basically equal to determinant of A into identity matrix. Okay, now from here you can get back to all these particular results, you can derive all these results and get to the conclusion. So I hope this particular thing was clear. Okay, now let us move on and solve some important questions to get a good understanding about today's lectures. Okay, now we are given with a question over here. Let us read the question and try to understand. Now what is given over the question? Now given there is a matrix which is a square matrix of order 3 cross 3, and you are given to calculate this particular result. Okay, so from here what we see, the determinant value is involved and we actually have the matrix. So let us firstly find the determinant value of the matrix A. So we find the determinant value from here. अगर इस डिटरमिनेंट वैल्यू को सॉल्व करते हैं, व्हाट विल एक्चुअली गेट? अगर इसको कुछ अगर ट्रांसफॉर्मेशन लगाना चाहते हो तो लगा सकते हो. ओके, सो व्हाट काइंड ऑफ ट्रांसफॉर्मेशन आई कैन सी फ्रॉम हियर? I see a transformation that is we can make 0 over here in this particular column, in this first column. So let us make, so for this I apply rho 1 goes to rho 1 minus 2 times of rho 2. Okay, now by simple this particular thing I get the result as this is 0 over here, and if this is 1, this is 0, and this is 2, this is minus 1, this is minus 1, this is 2, and if I change this, this result will be 1 minus of 2 times of, that is 4, 1 minus 4, that is minus 3, and 0 minus, and 0 minus of that is 0, and if I multiply 2 with this minus 2, this will be minus 2, and 0 minus of minus 2, that basically will be 2. Okay, so if you see this minus 1 is over here na, and if you multiply 2 with this, that is minus 2, and minus of minus 2 will be 2. So from here if you expand along the first column, okay, the result will be, if you expand along the first column, the result will be minus 1 की power minus 1 from here, because this particular element is I is equal to 2 and j is equal to 1, so this cofactor will have minus 1 in it, and the minor value will basically be multiplied by minus 3 into 2, that is minus 6, minus of minus 2, that is plus 2. From here the determinant value of A is basically equal to 4. तो डिटरमिनेंट का वैल्यू मिल गया. अब क्वेश्चन में क्या पूछा है ना, क्वेश्चन में पूछा है दैट इज एडजॉइंट ऑफ 2 टाइम्स ऑफ A. ओके, सो इसका डिटरमिनेंट का वैल्यू पूछा है. सो वी नो व्हेन एडजॉइंट्स आर मल्टीप्लाइड दिस नंबर ऑफ टाइम्स, जितना नंबर ऑफ टाइम्स मल्टीप्लाई होता है दैट इज द बेसिकली 2A की टाइम्स. ओके, डिटरमिनेंट ऑफ 2A टाइम्स ऑफ 1 2 3 there and the order is 3, so n minus 1, that is 2, and 2 की power 3. Okay, so and this particular result is given as 16 की power n, and this can be also written as 2 की power 4n. Okay, now from here I can get to the result, that is ना अगर कांस्टेंट को मैट्रिक्स से मल्टीप्लाई करके डिटरमिनेंट से बाहर निकालते हैं तो बेसिकली 2 की पावर n से मल्टीप्लाई होने वाला है, एंड साइमल्टेनियसली देयर इज अ पावर ऑफ 8, सो 2 की पावर 3 into 8 over here, and matrix determinant का value of A is 2 की power 2, so 2 की power 2 into 8 over there, and this is equal to 2 की power 4n, and from here if we solve, this will be basically 2 की power 8, that is 24, and this is 16, so if you add them you will get 2 की power 40. This will be 2 की power 40. From here the value of n basically will be 10. So I hope this particular solution was clear. So this was just an revision question, and this question was actually from the JEE mains only questions only. Okay, so I hope this particular solution was clear. Now let's move to the next particular important problem. Okay, based on this important division that we done. So this question says that given set of values of t which belongs to a real number for which this particular matrix is invertible. ना मैंने बताया था invertible का क्वेश्चन आने वाला है. अगर invertible है मतलब आपको डायरेक्टली चेक करना क्या है, the determinant of value should be non-zero. The determinant का जो value है that should be non-zero. So if you try to solve the determinant, what we see over here, there is one particular column is common. So if I see this, so from here cos t and this is e की power minus t cos t, and similarly these elements are given as e की power minus t minus of 2 times of sin t. This will be sin t. Okay, this will be sin t minus of cos t. Okay, similarly the elements are given as e की power minus t into sin t minus of 2 cos t, and similarly this element is given as e की power minus t sin t. Now if you compute the determinant value of this particular thing, now what I can do from here, let us take e की power t from the common from the first column, okay, and e की power minus t from the second column, and e की power minus t from the third column, and then we get the result as 1 1 over here, and this element results will be sin t minus 2 cos t, and this will be 2 sin t minus, sorry, this will be plus of cos t, and this will be cos t, and similarly here it will be minus of 2 sin t minus cos t, this will be sin t minus 2 cos t determinant, and this will be basically sin t. Now from here I can get the result, this is e की power actually t, okay, this is e की power t minus t, sorry, if you compute the product you will get e की power minus t, and from here I can do one transformation, that is rho 2 goes to rho 2 minus rho 1, and similarly rho 3 goes to rho 3 minus rho 1. So from here what I will get the result as is 1 0 over here 0 over here, and similarly this result will be this first row will remain unchanged, it is sin t minus 2 times of cos t, and similarly this will be minus of sin t minus of 2 times of sin t minus of cos t, and this element remains will change, that is 2 sin t plus cos t minus of 2 cos t minus sin t will basically be the result will be, so if you compute this result, this will be sin t, okay, the 2 sin t minus sin t is sin t cos t minus of 2 times of cos t, that will basically be plus of 3 cos t, okay, and similarly this result will come out as if you subtract cos t from this particular relation, it will come out 3 cos t, okay, 3 cos t minus of sin t, and similarly these elements will be sin t minus 2 times of cos t minus of, that is 3 times of sin t, okay, minus of cos t, similarly sin t, this will be 3 sin t, okay, and plus cos t. So from here if we expand, or if you try to take some common also, again apply some element transformation, you can do so, but if you try from here, this will be e की power minus t, from here if you try and compute the product and find out the determinant value, from here we can compute the product and find the determinant value. So let me rub this. Okay, now from here if I compute, that is e की power minus t into, and 1 over here, and into, that is sin t plus 3 times of cos t multiplied by, that is 3 sin t plus cos t minus of 3 cos t minus sin t multiplied by 3 sin t minus of cos t. Okay, so from here if you expand, you will get the result which is equal to non-zero result. Okay, from here you will get the result that the t, that this particular quantity actually get cancelled out and remains as 1. Okay, remains as 1, that is some constant quantity will be coming out from here. If you compute this result, this result will come out to something as 6 into e की power minus t. I hope this particular calculation is correct. I have calculated in my rough note. Okay, you can also try then calculation on your own and get to this result. So from here if you will get the result, the determinant of value hoga na, that is 6 into e की power minus t. Now from here if you actually get this particular result, that is 6 into e की power minus t, that means this particular result cannot be 0. This cannot be 0 for t की वैल्यू अगर रियल नंबर होगा ना तो इसका वैल्यू कभी 0 हो ही नहीं सकता, क्योंकि वी नो दैट e की पावर x का जो ग्राफ होता है ना, e की पावर x का जो ग्राफ होता है, दैट इज एक्सपोनेंशियल ग्राफ, दैट इज समथिंग लाइक दिस ग्राफ. ओके, दैट इज एक्सपोनेंशियल, and this exponential function can never be 0, can never be equal to 0, and similarly can never be negative number. So from here you can get the answer to this question. Basically will be the value of r, that value of t will be basically equal to real number. So this will be the correct answer to this particular question. So I hope this particular question was clear among all of you. So let us move on to the study the next particular important topic of today's lecture, that is the Gauss-Jordan method of solution of simultaneous linear equation by matrix method. Now before moving on to the Gauss-Jordan method, we have already talked about the solution of simultaneous linear equation by the methods of Cramer's rule using the determinant concept. And similarly also the determinant concept, we also have another important method, that is the Gauss-Jordan method. Okay, now this is also very similar. So for example, there is a many number of like you have n number of equations involving n number of variables. So with this we start our lecture. For example, there are n number of equations, okay, involving n number of variables, okay, similar to this is equal to d1, and we can write this a21 x2 x1 plus a22 x2 and so on. If you go on and write this a2n x2n xn is equal to d2, and similar there are n equations, that is an1 x1 plus and goes on to a of nn xn is equal to d of n. Now what we see, there are actually n equations satisfying the n variables. Now from here you can represent this particular equations in form of a matrix method, and that particular matrix which is very familiar, we already calculated the determinant value of this coefficient matrix. So similar to that, if we represent the coefficient matrix by some number, that is some letter, that is a, so we say this a is the coefficient matrix, and which is multiplied by this this unknown variable matrix, that is the jo jitna bhi unknowns hai, that is x1 x2 and x3 and so on up to xn. This particular matrix is a column matrix and represented as x, and is equal to this particular capital matrix, that is D. The D is basically this particular column vector, okay, this particular column matrix, okay. So in this way we can say there is a matrix equation involving this particular result, okay. So from here, this was basically the Gauss-Jordan method, which talks about for example, you have basically three equations involving three variable, let me write the three equations involving three variables, and from here what we actually try to do, and if we are actually supposed to find the solution using the Gauss-Jordan method, we will firstly find out the coefficient matrix, and the coefficient matrix will be nothing but the coefficient of all this, and in the given fashion of the rows in there, it should be represented in that way only. So this is a1, this is b1, this is c1, this is a2, this is b2, and this is c2. From here this will be a3, this will be b3, and this will be c3 matrix. And similarly the x matrix will be all the variables, that is x, y and z, and for the D, capital D matrix will be basically the constant, that is d1, d2 and d3. Okay, so I hope this particular thing is clear. Now what actually try to do, now this particular relation gives me the matrix equation, that is ax into d, x into is equal to d. Now from here we need to actually calculate and get the value of this unknown matrix as variables. So we can write this matrix x as A inverse into D. If we pre-multiply A inverse to both the sides, we can write this A inverse into D. So from here I can write x as adjoint of A divided by determinant of A multiplied into D. Okay, so from here we actually get to the result of this unknown variable matrix. So अगर पूछा गया है, our question में importance यहाँ आता है कि when to apply the Gauss-Jordan method and when to apply the Cramer's method rules. Okay, so अगर question में पूछा गया है, you are given with the three unknown equations and involving some variable quantity, and it is given that their particular solution has solution or no solution or trivial solution or any kind of information is given about the question, then you always go and apply for the Cramer's rule. But in case the question doesn't mention, that doesn't has this particular thing, but you have to actually calculate the variables values, then go with the Gauss-Jordan method. I hope this particular thing is clear. Now let us move and write some important thing regarding the Gauss-Jordan method. Okay. Now let me take up the important distinction that we already studied. Now similar to this particular concept, now there are actually two ways, okay, to solve this. Now firstly, the A inverse का value non-zero होना चाहिए, A inverse का value exist करना चाहिए. So for this A inverse to be existing, the determinant of A should be non-zero. There comes there are two concepts, that is this x is actually given by A inverse into D. So from here I can write one important thing, that is the adjoint of A into D is equal to null matrix, and there can be another possibility, that is adjoint of A into D is not equal to null matrix. Okay, there can be two possibilities, that is adjoint of A into D is null matrix and adjoint of A into D is not a null matrix. So if adjoint of A into D is not a null matrix and A is a non-singular matrix and A is a non-singular matrix, in this case we get directly to the solution that is known as a unique solution. Okay, we get to the important thing that is known as a unique solution. Now there can be another situation where this A into adjoint of A into D matrix is null matrix, not a null matrix, but the value of determinant of A is equal to 0. In such case, we directly get the result which is known as no solution, or the system of linear equation is basically inconsistent. The system of linear equation is basically inconsistent. Now there, and when the situation comes that is adjoint of A into the matrix D is basically a null matrix and simultaneously the determinant of A is also equal to 0, now in this case we get what important solution that is known as the infinite number of solution, and in this case also consistent, and we get infinite solution, So adjoint of A into D matrix is basically not a null matrix, and simultaneously the determinant of A non-zero, that is A is a non-singular matrix. In that only case we also get the result that is a unique solution. Now let us try and understand this particular, and by solving this particular question. Now from here in this question we are actually given with three particular equations involving three variables. Now if we try and check out this particular question, we firstly represent the coefficient matrix. Now let us take as the coefficient matrix, there is 1, 1, 1 over here, there is 2, 2 and minus 1 over here, there is 1, 1 and minus 1 over here. Now what our first step will be, will basically to calculate compute the determinant value of this particular matrix. Now if this determinant value is non-zero, then we can proceed further and get another equation. Now let us check out the determinant value, that is 1 into, if we expand on the first row, that is 1 into minus 2 into minus of minus 1, that is plus 1, so this will be minus 1. Similarly minus 1 into minus 2 minus of minus 1, that is again minus 1, and plus of 1 now 2 minus of 2, that is 0. So from here I will get this is minus 1 and this will be plus 1, so the determinant value will basically equal to 0. So determinant value is equal to 0, then what kind of case or solution I can get, that is maybe we get a no solution, or maybe we get to the result that is infinite number of solution. Now let us check and proceed further. Now for this we need to actually calculate the A inverse, and for A inverse calculation we have to calculate the value of adjoint of matrix A. Let us find out the adjoint by using the shortcut method. Okay, now if I calculate the adjoint by using the shortcut method, so for that we have to repeat the first two column and the first two row. Okay, now we delete the first column and the first row, and then we compute the adjoint as adjoint का जो value आने वाला, that is 2 minus of minus 1, that is minus 1 over here, and if we compute this minus 1 minus of 2 minus of minus 2, that is plus 1. Okay, this will be 2 minus 2, that will be 0, and similarly compute this results, that is 1 minus 1, that is 0, so we will write this 0 over here. Similarly if we compute this particular result, that is 2 minus 2, that is again 0, and if we compute this particular result, that is 1 minus of minus 1, that is 2, and similarly if I compute this particular result, oh sorry, I'm very sorry, I computed the result that is basically cancel out product. Okay, I'm very sorry, okay, this is basically cancelled out. Okay, okay, now what we see, this particular product is minus 2 minus of minus 1 minus 2 minus of minus 1, that is minus 1. Similarly this compute product, this particular product will be minus 1 minus of minus 2, that will be basically 1, and this will be 1, and this will be basically 0. Similarly this particular will be 1 minus of minus 1, that is basically 2. Okay, this particular value will be 2, 1 minus of minus 1, and similarly this particular value will be minus 1 minus of 2, that is 3, minus 3. Okay, minus 3. Similarly this value will be minus 1 minus of 1, that is minus of 2. Similarly this value will be 0. Similarly this value will be 2 minus of minus 1, that is 3, and this value will be 2, 0. Okay, so with this we actually get to the result of the adjoint of a matrix A. Now what we have to compute, we have to actually calculate this particular product, that is multiplying with the product of the constant matrix, that is a D matrix. Okay, now from here we can also see the capital D matrix can be 3, 3 and 1 over here. Now if we compute this result and check, if we compute this particular result and check, now let us compute this result and check. So from here what I get, I will get minus 3, okay, plus 6, minus 3 plus 6 basically plus 3, plus 3 minus 3, that will be 0. Similarly this particular element will be basically, let us check on this, 3 minus 6 plus 3, this will again be 0, and similarly this will again be 0. So we get an nothing but null matrix. So from here what we see, we will get infinite number of solution. From here we will get that the adjoint into determinant into the matrix D is also equal to 0, also equal to null matrix, and the determinant value is also equal to 0. So from here we get the condition that we get infinite number of solution. So we get infinite number of solution. Now how to solve this infinite number of solution? If you actually write the solution, if you have to write the solution, now what we will actually do, we will let any particular quantity that is equal to some constant, that is k. Now let us assume that z ka jo value hai, that is k. Okay, now let us start by taking the z value as k. Okay, so the variables was x plus y plus z is equal to 3, 2x plus 2y minus of z, which is equal to again 3, and x plus y minus z, okay, x plus y minus z is equal to 1. So from here if I label z as k, now what we can do, I can get the relation that is x plus y is equal to 1 minus 1 plus of k. Now again, and from here x plus y and z is given over here. Now again from here I can see that x plus y is basically equal to, from here if I solve, or let us solve from here on this particular thing, okay, to get to the result, that is x plus y, 2 times of x plus y is equal to 3 minus of z, that is k, that is equal to 3 minus of k. Now from here I will take one variable that is y. So y is equal to 1 plus k minus of x. Now if I put this in first equation, I will get 2x plus 2 plus 2k minus of 2x, which is equal to 3 minus k. Okay, or from here actually the x get cancelled, but we actually don't try to cancel the x and actually have to compute the or x or y in terms of k. So let us use the first equation. So if x plus, and the first equation, if we actually use the first equation, we also don't get the result, and this implies basically that we are getting a solution which is in terms of that is also, and finally we get the result. If we use the first equation and we get this particular result, that is x and x get cancelled, and this particular thing is not logical thing. Okay, so from here what we can say, that x ka value is 0 and y ka value is 0. So from here we can actually write this particular solution in terms that constant times of 0, 0 and 1 over here. So this can be infinite number of solution can be possible for this particular system of linear equation. So I hope this particular solution was clear. Okay, now let us move on to the another important short topic, which is about the matrix polynomial. Now let us study about what is matrix polynomial. Now before talking about the matrix polynomial, we have already talked about some important thing that is known as the Cayley-Hamilton theorem. Now while we were discussing about Cayley-Hamilton theorem, we will actually have to calculate some matrix polynomial. Now why do we need to study about matrix polynomial? Now for example, there is a function which is represented in terms of x, okay, unknown variable, that is x, that is a0 plus a1 times of x and so on up to an times of x to the power n. Now this is a polynomial equation involving unknown variable, that is x. Now similarly, if we replace x with this matrix, then we actually get the value. And if we put matrix in place of matrix x, okay, we put the matrix, okay, then we get the another important polynomial, that is basically and the polynomial we get, that is a0 into identity matrix a1 times of a and so on up to an into a to the power n, and this particular result is actually known as the matrix polynomial. So in this way, if we represent the matrix, then such thing is known as a matrix polynomial. So what you have to do, you have to replace the x with a to get the required matrix polynomial. You have to replace the x with a in order to get the matrix polynomial. Now why this matrix polynomial is important, you have to face some questions where the inverse is related in terms of some matrix polynomial and you have to find the value of the unknowns. So in these questions, matrix polynomial plays an important role. So I hope this particular thing was clear. Okay, now let us move on and study about the another important and very important concept, that is the reflection matrix. Okay, now this reflection matrix actually comes very handy while you actually study the concept of straight lines and coordinate geometry. So in coordinate geometry, you will face many questions where you have given some point and you have to actually calculate the reflection of the particular point about any particular line or any particular axis. So for that, matrix polynomial, reflection matrix plays an important role. Okay, if you directly want to remember the formula. So let us firstly study about reflection about x-axis. So if I talk about reflection on x-axis. Okay, so if I have x and y axis over here, and if I have a point which is represented in x and y, so if I take the reflection of this particular point about the x-axis and I get the point as p dash, so what I can say that the x coordinate, that is the ordinate value remains unchanged. Sorry, the ordinate value changes. Okay, the abscissa value remains unchanged, that is the value of x is the same, but what changes is basically the y gets changed by a negative term, that is the ordinate gets changed by negative. So from here what I can write this, that the new value of x, that is x1, can be written as 1 times of x plus 0 times of y, and similarly the y1 can be written as 0 times of x plus minus 1 times of y. I can write like this, and so on. I can write the new point of the reflection point, that is p dash, I can write in form of a matrix, and this matrix is basically equal to 1 0 0 minus 1 multiplied by x and y. So from here I can say that this particular matrix is actually the reflection matrix of any point about the x-axis. So I can say this is a reflection matrix of any point about the x-axis. Now similar to this, the concept of x-axis, that there will be a concept of y-axis. So if you reflect any point about the y-axis, so what you see, the value of y remains the same, but the value of x get changes by minus quantity. So if it is x comma y and you reflect among the y-axis, the value of x get changed by negative sign. So from here you will get the matrix. It's some matrix which is in the form like this, that is basically minus 1 0 and 0 1 over here. So this is actually known as the reflection matrix of any particular point on the y-axis. So I hope this particular concept is clear. Okay, now let us move on and study about the reflection about origin. Okay, now if I study about the origin, so what I can see, now any point which is reflected, for example there is a point x comma y and it is reflected about the origin, so both the sign get changed. Okay, in this case the reflected point get changed in both the sign, that is the sign of the x also changes and sign of y also changes. So from here what we can see, that this particular thing actually comes by multiplying the p dash matrix, which is equal to x1 and y1, the reflection, the image of this point is equal to x1 y1 is basically equal to minus 1 0 0 and minus 1 times of x and y. So this is actually known as the reflection matrix of any point about origin. Reflection matrix of p about origin, that is 0 comma 0. Similar to this, we also study another concept, that is reflection about a line, about the line x is equal to y. So if I talk about and say there is a point and you have to reflect that particular point about this particular line which passes through the origin, that is x is equal to y, if you have to reflect this particular point, that is p, that is x comma y, about this particular straight line, that is y is equal to x. So from here what we see, we actually get x1 and y1. So what we do in order to reflect this particular point, we actually take midpoint and actually solve this particular result. Okay, and this midpoint actually lies on this particular line. Okay, so from here we can directly solve this relation. So we can also solve this relation by taking the help of matrix. Okay, so matrix, reflection matrix, the x1 y1 is basically equal to, will be equal to 0 1 1 0. Okay, 1 0 times of x and y. So this is also known as the reflection matrix of any point which is reflected about the line x is equal to y. Now comes the another important, that is if the line is given some unknown line, that is x is equal to y is equal to x into tan theta. So if I say that the line is given in form of a basically in form of a slope is given, and the line is not the very same line that we actually see. Okay, that is a y is equal to x, that is the same straight line, but if the line is given in terms of some slope is involved, so how to see that? So from here we can directly remember the formula, and if you want to know the derivation of this particular formula, you can basically follow the lectures. Okay, and when I will be talking about the chapter of straight line, I will be basically discussing about this particular formula. Okay, so from here you can, if you reflect this particular, for example this particular is a line which is making an angle theta. Okay, because it is a tan theta is a slope, okay, which is making an angle theta. So this is the line, that is y is equal to x into tan theta. Okay, now if there is a particular point is given, that is P, that is x comma y, and it is reflected about this particular line, then the new point, that is x1 and y1, is basically related as x1 and y1 matrix can be calculated by multiplying matrix which is equal to cos of 2 theta minus of sine 2 theta and sine of 2 theta. That these matrices are easy to remember. If you see this matrix, there is a catch in the matrix. Okay, so what you see, okay, the whatever the element is over here, that is the negative times of this particular element, and the diagonal elements are same. Okay, so that is diagonal elements are same, but the negative sign actually comes over here. Okay, this negative particular sign comes here. Okay, this negative sign over here. Okay, so this is the reflection matrix, that is cos 2 theta sine 2 theta cos sine 2 theta and minus of cos 2 theta, which is multiplied with x and to y to get the reflection matrix. And this is actually known as a reflection matrix of any point which is reflected about the line y is equal to x into tan theta, y is equal to x into tan theta. Now similar to this, we also have another concept which is known as the rotation of any particular point through an angle, that is a theta. Now let us assume there is a particular point, okay, and we rotate the particular point by an angle theta to get the new point. So what will be the coordinate of that particular point can also be related with the help of this matrix concept. Now these things comes very handy in this coordinate geometry. So coordinate geometry में इसका proof मैं definitely दिखाऊंगा, ठीक है. So you don't go and ask me for the proof in the comment section, okay, but I will be talking about the proof in the chapter of straight lines. Okay, so be patient and follow up the lectures. Okay, so कोई अगर proof नहीं चाहता है ना, अगर directly इस चीज़ को memorize करना चाहता है, तो for the memorization purpose you can directly memorize in terms of matrix. Okay, so for example, there is a point which lies on this particle, that is x comma y, and this point actually makes an angle phi with the x-axis, and if it is rotated through an angle, this angle is this rotated angle is actually theta, and we get the new point. We get a new point. So what doesn't change? This is basically the distance of O and P. If it is r, so from here the distance of O and P dash remains the same. So if it is rotated, this is rotated in this particular fashion, that is in anti-clockwise way, this particular and the coordinate becomes x1 and y1. So from here we can relate x1 can be related as x into cos theta minus of y into sin theta, and similarly y1 can be related as x into sin theta plus y into cos theta. So from here what I can say and write in form of matrix, that is x1 y1 is basically equal to cos theta minus of sin theta, and this over here sin theta and over here cos theta times of what matrix, that is x and y. So from here we can actually rotate this particular point and to get the new point, that is p dash. So I hope this particular concept is clear, and this actually represents this particular system of equation. This particular system of equation defines the way in which this rotation happens. So I will take up the derivation of this particular thing in the chapter of straight lines. So with this, I hope the understanding was clear, and with this we come to the official end of this particular chapter of matrix and determinant. So अब जो topics है, that is basically demands only calculations. Okay, now the most important part of the chapter is actually completed, and I have taken a good number of examples to illustrate my sayings. Okay, so with this we have completed the today's goal. So I hope these particular goals are clear and you have understood the lecture nicely. Okay, so if you haven't understood the lecture, you can go back to the lecture and try to understand, and you have to take down the notes जो मैंने मैट्रिक्स रिफ्लेक्शन वाला कॉन्सेप्ट पढ़ाया, ठीक है. यू हैव डायरेक्टली टेक डाउन द नोट्स, डोंट गो एंड सी एंड कहाँ से आ रहा है. ओके, इफ यू आर एबल टू अंडरस्टैंड कि कैसे आ रहा है, आई हैव ट्राइड माई बेस्ट टू एक्सप्लेन कि कैसे आ रहा है. इफ यू आर एबल टू अंडरस्टैंड वेल एंड गुड, इफ नॉट देन डायरेक्टली कीप द थिंग्स एज रिमेंबर. अगर रिमेंबर नहीं भी रखोगे ना, कोई दिक्कत नहीं है, मैं स्ट्रेट लाइन में बताऊंगा कैसे आपको बेसिकली रिफ्लेक्शन वाला कॉन्सेप्ट और कैसे अप्लाई करके सॉल्व करना है. सो विद दिस वी बेसिकली कम टू द एंड ऑफ द लेक्चर, एंड आई होप दिस पर्टिकुलर लेक्चर सीरीज वाज क्लियर. मैट्रिक्स एंड डिटरमिनेंट का जो प्लेलिस्ट है वो डिस्क्रिप्शन बॉक्स में मिल जाने वाला है. आज का वीडियो के साथ आपको क्वेश्चन सीरीज में मिल जाने वाला है, चैप्टर प्रैक्टिस प्रॉब्लम एंड असाइनमेंट क्वेश्चन विल बी अवेलेबल इन द डिस्क्रिप्शन बॉक्स itself. So on coming lectures will be basically on the previous year questions. I will take out the JEE Mains previous year question at first, and then I will take out the JEE add-ons question. So with this I basically sum up the whole chapter of matrix and determinant. I hope the understanding was clear. और क्या क्या मैं चेंजेस ला सकता हूँ, you can definitely suggest me in the comment section below. So with this I come to the end of the lecture, and thank you.